Imagine an object in space so strange that even a black hole would look ordinary next to it. For decades, black holes have been seen as the kings of cosmic mystery, invisible monsters that swallow everything around them. But what if they're not really the champions of strangeness in the universe? What if there are phenomena even more bizarre, hiding in the depths of the cosmos? Get ready, because today you're about to discover 10 of them. Black holes have captured our imagination because of their terrifying nature. Nothing escapes their gravity, not even light. For many, that already sounds like the ultimate form of weirdness. But science is never satisfied with limits. And it is by pushing those limits that astronomers have come up with even crazier hypotheses. Ideas that, if proven true, would forever change our understanding of the universe. For example, could space harbor stars made of particles we've never seen on Earth? Or lonely planets drifting in complete darkness, far from any sun? With every discovery, we realize reality might actually be more creative than science fiction. And maybe, black holes are just the beginning of a much scarier list. In this journey, we'll explore 10 objects so exotic they could steal the throne from black holes as the weirdest things in the universe. Some are purely theoretical, others already have observational hints, but all of them share one thing in common. They completely defy common sense. And here's the best part. Many of these ideas aren't just wild speculation. They come straight from solid equations, the same physics that explain our own sun. If the math is right, it might just be a matter of time before we come face to face with one of these cosmic monsters. So, open your mind and hold on to your curiosity. Because if you thought black holes were already strange enough, you're about to learn that the universe still has far more bizarre tricks up its sleeve. In the end, you may realize that the weirdest thing isn't black holes, but the fact that we live in a cosmos that always has something even more unbelievable waiting to be discovered. And that suspense is exactly what makes space exploration so exciting. What we're about to dive into is not just science. It's almost philosophy, an invitation to imagine the limits of reality itself. Between the possible and the impossible, between theory and observation, lies a vast realm of mystery. And in that realm, the 10 strangest objects in the universe are waiting. So, without further delay, get ready to go beyond imagination. Let's start our list with something that could be the evolutionary step beyond neutron stars. The Quark Stars. Quark Stars. When a massive star dies, it may collapse into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. But what if gravity squeezes even further, pushing matter beyond the limits of neutron pressure? That's when something even stranger could form, a quark star. In a neutron star, particles are compressed until they become mostly neutrons, held together by quantum effects. But under even more extreme pressure, those neutrons themselves could break apart into their fundamental components, quarks. Imagine an entire star made not of atoms or neutrons, but of quark soup. This would be one of the densest objects in the universe, second only to black holes. A quark star could pack more mass than our sun into an object only a few kilometers wide. Its density and structure would defy anything we've ever seen. To us, it would look like a tiny, incredibly heavy cosmic pearl. Unlike black holes, however, quark stars wouldn't have an event horizon. That means they could still shine, releasing radiation, and potentially giving us clues to their existence. Detecting one would be like discovering a missing link between the known and the unimaginable. Some astronomers believe that certain mysterious signals we've observed in space, like unusual gamma-ray bursts, might actually come from quark stars. If so, we may already have indirect evidence of their existence, even without realizing it. The idea of quark stars also forces us to rethink the limits of matter. How far can we push particles before they become something entirely new? These objects would be living laboratories of fundamental physics, showing us conditions we can't reproduce on Earth. Quark stars could also play a key role in cosmic evolution. If confirmed, they would represent a stage between neutron stars and black holes, proving that the universe has far more variety in its stellar remnants than we imagined. The challenge, of course, is proving they exist. They're incredibly hard to distinguish from neutron stars or black holes. Without direct observation, they remain one of the most tantalizing what-ifs of astrophysics. Still, the math is solid. If matter can break down into quarks, And if gravity can reach that threshold, then quark stars should exist somewhere out there. Maybe we just haven't looked in the right place yet. And if stars made of pure quarks already sound bizarre, wait until you hear about an even stranger idea. Objects filled with vacuum energy itself, the mysterious Gravastars. Gravastars' black holes are defined by their terrifying nature. Once you cross the event horizon, nothing, not even light, can escape. But what if what we call a black hole isn't really one? What if, instead of collapsing into an infinitely dense point, a dying star transforms into something even stranger? A Gravastar? The idea of Gravastars was proposed as an alternative to black holes. Instead of having a singularity at the center, they would be filled with vacuum energy. In other words, the inside of a Gravastar wouldn't contain matter at all, but a strange form of energy that pushes outward with negative pressure, balancing gravity perfectly. From the outside, a Gravastar would look almost identical to a black hole. It would be nearly the same size, nearly as compact, and just as dark. But there's a crucial difference. Gravastars wouldn't have an event horizon. That means information could, in theory, escape from them, something impossible in true black holes. This solves one of the greatest puzzles in physics, the information paradox. If Gravastars are real, maybe information isn't lost forever as it falls into a black hole. Instead, it could be stored or even re-emitted by these exotic stars, changing everything we think we know about the laws of the universe. The inside of a Gravastar would be bizarre beyond comprehension. The vacuum energy would cancel gravity, creating a region where there's no pull inward and no push outward. If you somehow entered one, you would float freely, as if you were in a perfect cosmic void. Some scientists even speculate that Gravastars could explain dark energy, the mysterious force accelerating the expansion of the universe. If Gravastars were scattered throughout space, their vacuum-like interiors might be responsible for pushing galaxies apart. Of course, this is still a controversial idea. Many physicists argue that Gravastars are just mathematical curiosities, while others claim they might already be hiding in plain sight, masquerading as black holes we've detected. The problem is, telling the difference is incredibly hard. Gravitational waves might offer us a way forward. When two compact objects collide, the waves they release carry signatures of their true nature. If we find patterns that don't quite match black holes, Gravastars could finally be confirmed. Until then, they remain one of the most fascinating what-ifs in astrophysics. A cosmic doppelganger, a shadow of the black hole, waiting for its identity to be revealed. And if the idea of a star made of vacuum energy already sounds strange, hold on, because the next step takes us to even more exotic matter, the mysterious strange stars. Strange stars, neutron stars, are already some of the densest and strangest objects in the universe, but what if they could go one step further? That's where the idea of strange stars comes in. Objects made not just of neutrons, but of an even more exotic form of matter, strange quark matter. In theory, when neutrons are squeezed to unimaginable densities, they could break down into quarks. But instead of forming only up and down quarks, as in normal matter, strange stars would also contain strange quarks. This combination could make them more stable than anything else we know in the cosmos. Some physicists even speculate that strange quark matter might be the true ground state of matter. If that's the case, then neutron stars might be unstable, eventually decaying into strange stars over time. This would make strange stars more common than we think. They could already be out there, masquerading as regular neutron stars. What makes this idea truly unsettling is that strange matter might be contagious. If a fragment of strange quark matter ever touched ordinary matter, it could convert it into more strange matter. That means, in theory, a single strange star could transform other stars, or even entire planets, into copies of itself. This raises terrifying questions. Could the universe one day be consumed by a chain reaction of strange matter, spreading like cosmic wildfire? Or has this already happened in distant regions of the cosmos, far beyond our reach? Detecting strange stars is incredibly difficult. They might look almost identical to neutron stars, emitting similar radiation and pulses. Only subtle differences in mass, radius, or thermal behavior could reveal their true identity, and these are incredibly hard to measure. Yet, the possibility remains deeply compelling. Strange stars would represent an entirely new form of stable matter, something never observed on Earth but possible in the extreme environments of space. They would show us that the building blocks of reality are far stranger than we imagined. If confirmed, they would force us to rethink not only stellar physics, but also the nature of matter itself. What we consider normal could just be a fragile exception, with strange matter being the real default of the universe. For now, strange stars remain a hypothesis, a frightening and fascinating reminder of how little we truly know about the cosmos. But if they do exist, they may already be shaping galaxies in ways we can barely imagine. And if the thought of contagious stars made of exotic particles isn't strange enough, our next stop is even darker. The silent ghosts of the far future. The black dwarfs. Black dwarfs. If you look up at the night sky today, you won't see a single black dwarf. Not because they don't exist, but because the universe simply isn't old enough to have created one yet. Black dwarfs are the final stage in the life of white dwarfs, those small, dense stellar remnants left behind after stars like our sun die. But here's the catch. For a white dwarf to cool completely and become a black dwarf, it would take trillions of years. That means that right now, there are no black dwarfs in the universe. With the cosmos being only 13.8 billion years old, it hasn't lived long enough for even one to form. When we talk about black dwarfs, we're peeking into the farthest possible future, into an era we can barely imagine. So what exactly is a black dwarf? Essentially, it's a white dwarf that has cooled down so much it no longer emits visible light. It would be a dead, cold, and invisible star, a cosmic ghost drifting silently through space, a memory of a sun that once shined. What's bizarre is how completely undetectable they would be. With no light or heat, black dwarfs would wander the galaxy unseen. A collision with one would be catastrophic, but we would never notice it coming until it was too late. Even stranger, theories suggest that black dwarfs might not be entirely quiet. In time frames so vast they make our entire history look like a blink, rare nuclear reactions could still occur inside them, triggering delayed supernova explosions. Imagine a star that has been dead for trillions of years suddenly exploding in a final, eerie burst of light. These would be the last fireworks of the universe, the ultimate cosmic finale before everything goes dark. It gives black dwarfs a haunting quality. They don't just represent the death of stars, but the death of light itself. Another fascinating point is that humanity will never actually observe a black dwarf. They are one of the few astronomical objects we can predict with confidence but will never witness. They are destined to exist long after humanity, and perhaps even the universe as we know it, is gone. Black dwarfs are reminders of the impermanence of everything. Even stars, which to us seem eternal, have expiration dates. One day, every shining star in the sky will cool into silence, leaving behind only these invisible remnants. They symbolize the ultimate fate of stellar evolution, a universe growing colder, quieter, and darker with time. And while that may sound depressing, it's also a glimpse of the cosmos's grand, inevitable story. But if the deathly silence of black dwarfs already feels unsettling, the next object on our list flips the idea of black holes on its head, the bizarre and theoretical white holes. White holes. Imagine a cosmic object that doesn't pull things in, but pushes everything out. Nothing can enter it, only escape. That's the concept of a white hole, the exact opposite of a black hole. While black holes are famous for devouring anything that comes close, white holes would act as cosmic fountains, spewing matter and energy into space. This isn't just science fiction. White holes arise naturally from Einstein's equations of general relativity, the same equations that predict black holes. On paper, they're perfectly valid solutions to the laws of physics. The mystery is why we haven't seen one yet, or if they could even exist in a stable form in our universe. In simple terms, if black holes are regions where nothing can escape, white holes are regions where nothing can enter. They would have singularities not in their future like black holes, but in their past. That means they could have been ejecting matter since the beginning of time, fueling parts of the universe with their strange eruptions. Some scientists have suggested that white holes might be linked to black holes, forming bridges known as wormholes. In this scenario, anything swallowed by a black hole in one part of the cosmos could emerge from a white hole in another location, or even another universe entirely. In other words, white holes could be cosmic portals. The problem is, they would likely be extremely unstable. A white hole could collapse instantly under the slightest disturbance, possibly transforming into a black hole instead. That instability might explain why we haven't seen any. They simply don't last long enough to be detected. Still, some theories propose that white holes could appear at the end of a black hole's life. As a black hole evaporates through Hawking radiation, instead of fading into nothingness, it might explode outward as a white hole, releasing all of its contents back into the universe. One bold idea even suggests that the Big Bang itself might have been a massive white hole, an explosion of unimaginable energy and matter from a single point, marking the beginning of everything we know. In this sense, our universe could be the product of the largest white hole of all. If true, white holes would completely change our perspective on cosmic evolution. Instead of being only destructive, the universe would also have engines of creation, balancing the cosmic cycle of matter and energy. Though still theoretical, the concept of white holes reminds us of the symmetry that seems to underlie the universe. For every force of attraction, perhaps there's a force of repulsion. For every abyss that swallows, there may be a fountain that gives. And if white holes already sound mind-bending, the next object is just as unsettling. Planets wandering alone through the darkness of space. The mysterious rogue planets. Rogue planets. Imagine a planet the size of Earth, or even Jupiter, wandering through space completely alone with no star to call home. These are the rogue planets, also known as orphan planets. Unlike the worlds we're familiar with, which orbit stars, rogue planets drift endlessly in the cosmic dark, like castaways lost at sea. How do they form? Astronomers believe many rogue planets started in regular star systems, but were violently ejected by gravitational interactions. Others may have formed directly in interstellar clouds, never having orbited a star at all. Either way, the result is the same: a lonely world adrift in the void. Without a star to provide light or warmth, these planets appear lifeless and frozen. But surprisingly, some scientists think they might still host life. If they have internal heat sources, like radioactive decay or geothermal activity, liquid oceans could exist beneath icy surfaces, creating hidden, habitable environments. This radically changes how we think about where life can exist. Maybe it doesn't always need a star. Perhaps life could survive in secret, deep below the surface of worlds drifting in eternal darkness. If so, the universe could be filled with far more potential habitats than we ever imagined. Detecting rogue planets is extremely difficult. Since they don't reflect starlight, they're almost invisible. Astronomers rely on gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity bends the light, briefly revealing its presence. So far, we've identified a handful of candidates, and the numbers are astonishing. Some studies suggest there may be more rogue planets than stars in our galaxy, possibly billions of them wandering unseen through the Milky Way. The unsettling part is imagining one drifting into our solar system. Even without colliding, its gravity could disrupt planetary orbits, throwing worlds out of balance. It's a cosmic nightmare scenario, an invisible giant suddenly rewriting the architecture of our system. On the other hand, if one of these planets had life, it would be the loneliest civilization imaginable. No sunrise, no night sky full of stars, only eternal blackness, illuminated by volcanoes, deep oceans, or glowing organisms. Rogue planets remind us that the universe isn't just made of orderly systems, it's also full of wanderers, nomads of the cosmos, drifting endlessly with no destination. They're a haunting example of nature's unpredictability. And if lonely, starless planets sound eerie, the next concept is even more surreal. Iron stars, stellar corpses made entirely of metal, waiting for the far, far future. Iron stars. The stars we know shine because of nuclear fusion. Hydrogen fuses into helium, then into heavier elements all the way up to iron. But iron is the end of the line. It doesn't release energy when fused. When a star builds up too much iron, it collapses. But what if, in the far future, the universe gives rise to stars made almost entirely of iron? These are the hypothetical iron stars. In theory, Iron stars could form in an unimaginably distant future, when nuclear processes have had trillions upon trillions of years to unfold. Over time, through proton decay and quantum tunneling, matter in white dwarfs and neutron stars could gradually transform into iron. The result would be dark, dense, metallic stellar remnants. Unlike the stars we see today, iron stars wouldn't shine. They wouldn't generate light or heat through fusion. Instead, they'd be cold monuments of metal, scattered across a dying universe. In their silence, they would represent the ultimate fossilization of stellar evolution. The concept of iron stars forces us to confront the long-term fate of the cosmos. In an era when fusion has stopped and black dwarfs and iron stars dominate, the universe would no longer sparkle with galaxies and nebulae. It would be a vast graveyard of cold metallic remnants. Some models suggest that iron stars could even collapse further. Quantum instabilities might cause them to shrink into black holes over incomprehensible timescales, slowly feeding the last gravitational monsters of the cosmos. Even at the end of time, transformation wouldn't cease. Strangely enough, these stars could outlast everything we know today. While our sun has only billions of years left, iron stars could persist for nearly eternity, shining not with light, but with the eerie permanence of dead matter. Iron stars are more than just theoretical curiosities. They remind us that the universe is a story with many chapters, and we are still in its early pages. What looks eternal to us, the brilliance of stars, is actually fleeting when compared to cosmic time. The very idea of stars made of metal challenges our imagination. They sound like relics from a dystopian cosmos, long after life and light have vanished. Silent, metallic giants waiting in a frozen, endless night. Though we'll never see one, iron stars paint a picture of the ultimate destiny of matter, from fire to metal, from light to silence. A poetic, if unsettling, conclusion to the life cycles of stars. And if the idea of a universe filled with cold metal isn't strange enough, the next object is even wilder. Infinitely thin, unimaginably heavy filaments that could slice through space itself. The mysterious cosmic strings. Cosmic strings. Imagine invisible threads, thinner than an atom but so massive they could warp space-time itself. These are the hypothetical cosmic strings, relics from the earliest moments after the Big Bang. If they exist, they would be some of the strangest and most dangerous structures in the universe. Cosmic strings aren't made of ordinary matter like stars or planets. Instead, they are pure energy trapped in ultra-thin filaments. Their density would be unimaginable. A single kilometer of cosmic string could weigh more than the Earth. It's a concept that defies our everyday sense of scale. What makes them truly fascinating is their gravitational effect. Passing near a cosmic string would distort the light of distant stars in bizarre ways. Astronomers believe we could detect them by spotting unusual gravitational lensing effects that don't match anything else we know. Some theories suggest cosmic strings could have shaped the early universe. Acting like invisible scaffolding, they might have guided matter into clumps, helping galaxies form where they are today. If so, we owe much of the structure of the cosmos to these mysterious filaments, but they also come with terrifying possibilities. If a cosmic string were to pass through our solar system, its gravitational pull could shred planets apart, tear orbits to pieces, and leave nothing recognizable behind. All without emitting a trace of light or sound. Even stranger, some physicists think cosmic strings might be connected to extra dimensions. In certain versions of string theory, they could be remnants of higher dimensional structures, hinting at hidden realities we cannot see. Despite decades of searching, no conclusive evidence has been found. But astronomers continue scanning the skies for signs because confirming their existence would revolutionize physics, offering a direct link to the earliest seconds of the universe. Cosmic strings remind us that the universe might contain shapes and structures completely unlike anything on Earth. Not just spheres or disks, but infinitely long, ultra-thin scars stretching across the cosmos. Whether they exist or not, they represent the kind of mind-bending ideas that make astrophysics so thrilling. Objects that sound like pure fantasy, yet emerge naturally from real mathematics. And if invisible threads slicing through space seem bizarre, Wait until you hear about the possibility that our universe itself might be just one of countless bubble universes. Bubble universes. We often think of the universe as everything there is. But what if our universe is just one among many, floating like a bubble in a vast cosmic sea? This is the concept of bubble universes, one of the boldest and strangest ideas in modern cosmology. The theory comes from the concept of cosmic inflation, a rapid expansion that occurred just after the Big Bang. Some models suggest that inflation doesn't stop everywhere at once. Instead, it creates isolated regions of space, each forming its own universe with unique physical laws. This means there could be universes where stars never form, universes where gravity is far stronger or weaker, or even universes almost identical to our own. Our universe may simply be one bubble in an infinite cosmic foam. One of the most mind-bending implications is the idea of universe collisions. If two bubble universes were to collide, the energy released would rewrite the laws of physics within them, erasing everything we know. Some scientists have even searched the cosmic microwave background for scars of such collisions. The bubble universe hypothesis also connects to one of physics' greatest mysteries: dark energy. Why is its value so perfectly suited for life? Perhaps it's not special at all. Maybe we just happen to live in one of the rare universes where the conditions allow galaxies, stars, and life to exist. This explanation removes the need for fine-tuning or intelligent design. Instead, it relies on sheer numbers. With countless universes, it's inevitable that at least one has the right conditions for us, and we just happen to be in it. Of course, the challenge is evidence. Other universes would be fundamentally disconnected from ours, making direct observation nearly impossible. For now, the idea remains a bold but unproven possibility. Still, the concept reshapes how we view reality. If bubble universes exist, then our entire cosmos is just a tiny fragment of a much larger multiverse, a single droplet in an endless ocean. It's a humbling thought. Everything we know, from galaxies to atoms, could be just one version of reality among infinite others. And we may never know the full extent of what lies beyond our bubble. But if other universes already sound unbelievable, the next strange object brings us back to the shadows of our own cosmos: the invisible, massive, compact dark matter objects. Compact dark matter objects. Roughly 85% of all matter in the universe is invisible. We call this mystery dark matter. It doesn't emit, reflect, or absorb light, but we know it's there because of its gravitational pull. But what if dark matter isn't just scattered particles floating around? What if part of it is condensed into massive invisible bodies? These are the hypothetical compact dark matter objects. Think of them as ghost stars or phantom planets. They could be drifting through space right now, completely undetectable to the naked eye. Unlike ordinary matter, they wouldn't shine or interact with light, making them invisible to telescopes. We would only notice them through the subtle ways they bend gravity around them. Astronomers search for them using gravitational microlensing. When one of these dark objects passes in front of a distant star, its gravity bends the starlight, creating a temporary signature that can reveal its presence. It's like catching a shadow by the way it distorts the light behind it. If these compact objects exist, they could help explain one of the biggest puzzles in astrophysics. What exactly makes up dark matter? Instead of being only tiny particles, dark matter might also form into giant, unseen structures scattered across the galaxy. But the thought is terrifying too. Imagine one of these objects wandering into our solar system. Its gravity could disrupt planetary orbits, fling worlds into space, or even collide with Earth, and we'd never see it coming until it was too late. A silent cosmic assassin. On the other hand, these invisible giants might have played a crucial role in shaping the universe. Their gravity could have acted as seeds for galaxies, pulling ordinary matter together to form the cosmic structures we see today. Without them, the universe might look completely different. Despite decades of searching, no definitive evidence has been found. But the idea continues to intrigue scientists because the math fits, and the universe's behavior suggests something unseen is out there. Compact dark matter objects are a chilling reminder that invisibility doesn't mean non-existence. The most powerful forces in the cosmos may be the ones we can't see. If they are real, then the night sky hides far more than shining stars. It hides silent giants shaping the universe from the shadows. And if invisible stars made of dark matter sound strange, just wait. Our next candidates are even more mind-bending. Blazing stars made entirely of antimatter. Antimatter stars. We know the universe is made mostly of matter, protons, neutrons, and electrons that form atoms, stars, and galaxies. But there's a cosmic mystery here. For every particle of matter, physics predicts an identical twin of antimatter. When matter and antimatter meet, they annihilate in a burst of pure energy. So here's the question. What if some stars are made not of matter, but of antimatter? These hypothetical antimatter stars would look almost identical to normal stars from afar. They would shine, burn, and radiate just like our sun. The difference is in their chemistry. Instead of protons and electrons, they'd be made of antiprotons and positrons. If an antimatter star existed near a regular star, the results would be catastrophic. Any contact between matter and antimatter would trigger explosions powerful enough to erase both in flashes of gamma rays. Entire solar systems could vanish in seconds. Astronomers are hunting for signs of such stars by looking for unusual gamma ray signatures. When antimatter interacts with regular matter, it leaves behind very specific energy patterns. Some unusual cosmic rays we've detected might even hint at the presence of antimatter regions in the universe. The big mystery is, where would these stars come from? One theory suggests that in the early universe, after the Big Bang, some regions might have had slightly more antimatter than matter. Those pockets could have condensed into stars and galaxies of pure antimatter, separated from ours by vast distances. If true, it means there could be entire antimatter galaxies out there, invisible to us until they interact with matter and release their deadly energy. It's a chilling thought. Twin versions of the universe, made of a mirror substance that cannot coexist with ours. Finding an antimatter star would not only solve one of physics' biggest mysteries, the imbalance between matter and antimatter, but also prove that the universe is far stranger than we ever imagined. They may be hiding in plain sight, disguised as ordinary stars, waiting for the day we detect their deadly fingerprints in the gamma-ray sky. And if antimatter stars sound like something out of science fiction, the next cosmic enigma is even more haunting. The mysterious dark energy stars, fueled by the very force that drives the expansion of the universe. Dark energy stars. Dark energy is one of the greatest mysteries in physics. It makes up nearly 70% of the universe and is responsible for its accelerated expansion. But what if dark energy doesn't just fill space? What if it can also form stars? That's the idea behind the hypothetical dark energy stars. Unlike normal stars, which shine because of nuclear fusion, dark energy stars would be powered by the repulsive force of dark energy itself. Instead of collapsing under gravity, they would resist it, balanced by a kind of negative pressure that holds them stable. From the outside, a dark energy star might look very similar to a black hole, small, dense, and incredibly compact. But the difference is crucial. Unlike black holes, dark energy stars wouldn't have an event horizon. That means light and information could still escape, making them observable in ways black holes aren't. Some scientists have even suggested that objects we currently call black holes may actually be dark energy stars in disguise. If true, this would completely rewrite our understanding of cosmic giants. Instead of singularities hidden behind horizons, we'd be looking at exotic stars filled with the mysterious substance accelerating the universe. The implications are staggering. If dark energy stars exist, they could provide a natural explanation for both dark energy and black holes, uniting two of the biggest puzzles in astrophysics into one phenomenon. Of course, this is still highly speculative. Detecting them would require careful observation of gravitational waves and light patterns during cosmic collisions. Subtle differences between a true black hole and a dark energy star might finally reveal the truth. If confirmed, dark energy stars would change not only how we see stellar remnants, but also the future of the universe itself. They would be proof that dark energy isn't just a background force. It can take shape, gather, and form cosmic objects of its own. These stars would be among the strangest creations of nature. Silent, invisible engines powered by the force that shapes the destiny of the cosmos. And if dark energy stars sound like the ultimate mystery, the next object is even more paradoxical. Stars made not of ordinary matter, but entirely of dark matter. Dark matter stars. We know dark matter is out there. It makes up most of the matter in the universe, but we still don't know what it is. Normally, it doesn't emit or interact with light, which is why we can't see it directly. But what if, under the right conditions, dark matter could form stars? These are the hypothetical dark matter stars. In theory, during the early universe, vast clouds of dark matter might have collapsed under their own gravity. Instead of igniting nuclear fusion like normal stars, these objects would be powered by the annihilation of dark matter particles. That process could release radiation, making them glow faintly in the dark. What makes dark matter stars so strange is that they wouldn't behave like anything we've ever seen. They could be much larger than normal stars, possibly as massive as galaxies themselves, yet still invisible to our telescopes. Their light, if any, would be subtle and difficult to detect. Some scientists suggest that dark matter stars might have been the first stars of the universe, shining before ordinary stars ever formed. If true, they could hold the key to understanding how galaxies and cosmic structures came to be. There's also a chilling possibility. Some dark matter stars might still exist today, lurking in the shadows of galaxies. We wouldn't see them, but their gravitational influence could shape the orbits of nearby stars and planets, silently sculpting the universe from the dark. Detecting one would be groundbreaking. Astronomers are looking for unusual radiation signatures that don't match any known star, which could point to dark matter stars. Gravitational lensing might also reveal their hidden presence. If proven real, these stars would completely redefine our understanding of dark matter. It wouldn't just be an invisible background ingredient of the cosmos, it would be an active, creative force, capable of building structures of its own. Dark matter stars remind us that the universe may be hiding entire families of objects we've never seen before. They're the ultimate cosmic phantoms, vast, powerful, and invisible. And if stars made of dark matter sound unbelievable, our final stop takes us into a cosmic paradox that challenges the very foundation of reality itself: the multiverse. The multiverse. We often think of the universe as the sum of everything: space, time, matter, and energy. But what if our universe is just one of many, part of a vast cosmic collection known as the multiverse? The multiverse is one of the most mind-bending ideas in physics, and it comes in several forms. One version suggests that new universes are born from cosmic inflation, each with different laws of physics. Another comes from quantum mechanics. With every decision, the universe could split, creating parallel realities for every possible outcome. If true, it means there might be universes where gravity is stronger, stars never form, or even universes where life never had a chance to exist. Equally, there could be countless universes almost identical to ours, with versions of you and me living slightly different lives. Some physicists even argue that the multiverse may solve one of the biggest mysteries in science: why the physical constants of our universe are so finely tuned for life. Instead of being a cosmic coincidence, maybe we just happen to live in one of the rare universes where the numbers worked out. The problem, of course, is evidence. Other universes would likely be forever beyond our reach, separated from us by barriers we cannot cross. For now, the multiverse remains a theoretical framework, a possibility, not a proven fact. But the implications are staggering. If the multiverse exists, then everything we see, galaxies, stars, black holes, would be just a tiny fragment of a much larger, infinite reality. Our universe would be just one chapter in an endless library of possibilities. Whether or not we can ever prove it, the idea of the multiverse forces us to expand our imagination. It reminds us that reality may be far bigger, stranger, and richer than we could ever dream. And with that, we've reached the end of our journey through the 10 strangest objects in the universe, stranger even than black holes. From Quark Stars to Gravastars, From white holes to bubble universes, each possibility shows us how little we truly know about the cosmos. The universe still hides countless secrets, and maybe, just maybe, the weirdest discoveries are yet to come.